Welcome to our sixth video in our Python for Artificial Intelligence and Machine Learning series. Today, we will explore two important data structures, that is tuples and sets. These collections expand our ability to organize and manipulate data in different ways, which will be valuable as we progress towards more complex AI and machine learning applications. Understanding when to use tuple versus list versus sets is an important skill for efficient programming. Comment tuple and sets mode on in the comments below. I would like to see who is learning with me today. So let's see what is tuple. So tuples in Python are ordered list, just like lists that we covered last in our last video. But there is one key difference: they are immutable. That means once a tuple is created, you can't change its content. You can think of tuple as a read-only list. This immutability comes with some advantages like better memory efficiency and the ability to use tuples as keys in dictionaries. In machine learning, tuples are super useful for storing fixed structures like coordinates, RGB color values, or dimension settings that I will show you in the example very soon. Now let's see how we can create tuples and how we can use tuples. So there are few different ways to create tuples in Python that I will show you in a bit. The most important is by using parentheses, but you can also create them without parentheses. That is called tuple packing. One important tip: if you are creating a tuple with just one item, don't forget the comma at the end. Without it, Python won't treat it as a tuple. Python can treat that as a string, as a number, or whatever kind of data you are providing. I will show you that in a bit. So Python also supports tuple unpacking, which means you can assign multiple variables at one time. So this is how you can do tuple unpacking. So this is especially useful when functions return multiple values or when you want to break them apart in a data structure in a clean way. So let's jump to our coding editor and see how we can create tuples. So as I said, you can create tuple in two ways. One, you can just give the parenthesis. By giving this parenthesis, it is going to go ahead and create a tuple for you. Or you can go ahead and use a word that use a method named tuple. This will also go ahead and create an empty tuple for you. So over here you can see it is going to create an empty tuple like this. Now, creating a tuple with items. So this is how you can create a tuple with items, that is coordinates 10, 20, 30. And when I click on print coordinates, this is how it will be printed. So 10, 20, 30. So this is how we saw we can create tuples in multiple ways. Now, there was one important point that I told you. Don't forget comma at the end when you are giving a single item inside a tuple. I will show you how. So I have taken two examples, one without comma and one with comma. Okay, so I will go ahead and run it, so you will automatically understand why it has been said that you have to use comma if you are using a single item inside a tuple. So if I go ahead and run it, so you will see over here that it has considered it as integer instead of a tuple, because you have not given a comma over here. But afterwards, when I have given a comma, it has considered that as a tuple. So it is based on the item that you're providing inside the tuple. So right now it is 42. If I say ABC, it will become string. Let me go ahead and run again for you. Okay, so okay, name, okay. I will just go ahead and put it as a string. See, now it has become a string. So that is how it works. That is why it is important to put a comma at the end. Now, let's see what is tuple packing. So we saw how we can create with parentheses, how we can create with a method tuple, how we can, and once we create it, we have to make sure that we use comma. Now, moving towards the next style of creating a tuple, where you can use tuple packing. So over here, you don't have to mention any parentheses to create a tuple. You just go ahead and provide a comma separated value, and it is going to go ahead and create a tuple for you. So over here, I have given person and I have given some values. If I go ahead and run this, you will see your tuple is been created, and these are the content of your tuple. Okay. Now tuple unpacking. So now the person tuple has been created, so it has been packed. Now you have to unpack it into different variables, so you can do that also. So right now I am using name, age and job based on the elements that we have added inside the tuple. So over here we are doing tuple unpacking, based on which it is going to go ahead and print those values for us. So now I have assigned these values to these variables, and when I print those variable values, it is going to go ahead and give us the items which were inside the tuple. Now let's go back. Now let's talk about tuple operations and tuple methods. So even though tuples are immutable, as I said you, meaning you can't change them, they will support useful operations just like lists that we have. You can access items using indexing and slicing. Tuple also have a couple of handy methods like count methods that tells you how many times a value has been appeared, and index, which gives you the position of the first match. We will see that in a bit. So there are these are especially helpful when working with fixed structures in AI projects like model setting or data set shapes that shouldn't change. So let's jump back to our code editor and see some examples about tuple operations. So what I have did, guys, so there are two types so over here what I have did, I have gone ahead and given all the best possible operations that we can do as onto the tuple. So over here, first I am defining the tuple. So these are the elements of our tuple from 10 to 10 to this 20. Now, if I go ahead and click run my tuple and to fetch the value at the index of 3, that is, so it starts with 0 like list. So this is 0, 1, 2, 3. So let's see what it gives. So you can see it goes ahead and gives me 40. So that is the on the third index number, that's why it is giving. So the same way, if I go ahead and say 0, it is going to go ahead and give me 10. So that is how you can use indexing in tuples. Now you can also use slicing. So remember, whenever you see slicing like we did in list that I explained very well, 1:3, that means it will start from 1 and it will end n minus 1, that is 3 minus 1, that is at the index of 2. So over here when I run 1:3, so 0, 1, so this is 1, so it will start with 1 and it will end with 2. So 1, 2, there should be only two values which should go ahead and which will go ahead and see, only two values came in, 20 and 30. So that is how you can do slicing in tuples. Now you can also do concatenation in tuples, where you can use the operator plus operator to do the concatenation. So if I go ahead and run this, it is going to concatenate the two tuples into one tuple, and this has now become a combined tuple, which is 1, 2, 3, 4. Now you can also run use multiplication for repetition of the tuples that you have. So right now we have the tuple value as 1, 2, 3, 4. If we are going to go ahead and run repetition, it is going to go ahead and repeat the values for us. So we have done it 2 times. So that is how you got this values over here. Now, so I will go ahead and this is not the tuple that we have multiplied over here. If you're getting confused, this is this tuple that it has been multiplied. That is my tuple. So I have used my tuple over there. That's why this value and this value is different. So don't get confused. Now, talking about the membership, again, this membership we would be checking in our my tuple that we have declared over here. So you can also use membership in. Okay, by using this, you can check whether the element is present in the tuple or not. So if I go ahead and run this, so 30 is present in our tuple, 50 is also present in our tuple. Oh, sorry, 50 is not present. So it is going to give us true and false. See, true and false. That is how it works. Now, next thing, I was speaking about a method. So again, let me go ahead and create a tuple for us with these values. Once the tuple is created, now we are going to check how many times 20 has been appeared as an element as part of the tuple. So if I go ahead and run this, so this count method is going to help us identify that how many times 20 has been repeated as part of the tuple. So if I go ahead and run it, you can see it is saying 2 times. So it can see the value 2 times inside the tuple. Now, if I go ahead and use index method, what this index method is going to do is when you search with the value, it is going to go ahead and give you the first index where it found the value first. So 30 comes here. So okay, it is going to be 0, 1, 2. So it is going to give us the index number as 2 over here. See, it has written 2. Now, let's jump back to our screen and let's talk about some practical uses of tuples, how it has been used. So tuples are especially useful in real world scenarios where data shouldn't change. Because they are immutable, they are perfect for things like declaring RGB color values, geographical coordinates, or any fixed structure which should not change. So they are also commonly used to return multiple values from a function that I will show you in a bit, which makes unpacking clean and efficient. So in machine learning, tuple comes in handy for representing things like hyperparameter setting, data set statistics, or model dimension. And since tuples are more memory efficient than lists, they are a smart choice when dealing with large data sets in AI workflows. So let's jump back to our VS Code and let's see some examples of our practical use cases. So as I said, these kinds of tuples are used to define values of RGB color. So these are one example of RGB color. By using this, you can define the value of RGB color over here. The same way, the geographical coordinates, these are also kind of constants which does not change. So this is where it can be used once again. Okay, yes. Okay. So now, third, I said you that we can use it as a function also for packing and unpacking. So over here, what you can see that I have written multiple values as part of my function. So I have declared a function over here, get stats, and inside this function, I have declared 3 variables, and I am returning all the values of these 3 variables all together to which is going to be which is going to go ahead and get saved as a tuple. So over here you can see stats is equal to get stats. So when I go ahead and print stats, it is going to show you how multiple values which are been returned can be saved as a tuple. So see, all the values which has been written, it has been saved inside a tuple. Now another example. So over here, we saw how multiple values from a function can be stored inside a tuple. Now we are going to go ahead and see the values which are being returned and being stored as a tuple, how we can unpack it. So for unpacking, what we are doing is we are defining 3 variables over here, mean, median, and standard deviation is equal to get stats. So now when I go ahead and print the value for these 3 variables, it is going to go ahead and print these 3 different values that has been defined over here, that is mean, median, and standard deviation. Now, one real life example where tuples can be used. So for example, suppose if you define config as a tuple where these are the values that has to be used. So you can actually unpack those and assign it to the activation, learning rates, and epochs that we use while creating a model. And that is how it can be used. That is a real life example that you can consider of in your brain. Now let's move ahead and move to another important concept, that is sets. So sets in Python are collections that store unordered unique elements. That means if I save 1, 2, 2, 3, 4, so it is not going to save element 2 times. It will only save it once because it only saves unique elements. It does not saves duplicate elements. Their key feature is that they automatically eliminate the duplicates for us. So if you try to add a duplicate value, it's simply ignored. You will not find that inside the set. So this makes sets extremely useful when you need to remove duplicates or track unique values. Under the hood, sets are implemented using hash tables, which makes testing like checking if an item exists or not very fast compared to the other data types. In data science and machine learning, sets comes in handy for tasks like feature selection, eliminating duplicate samples, and efficient intersection operations that we are going to perform towards our data sets. So let's go ahead and see what's next. So now we just understood that what exactly the sets is. It's an unordered list and it avoids duplicate. So let's now see how we can create a set in Python, which is very simple. You can define a set using curly braces, uh, with elements inside it, or by you yes, you can do that. Otherwise you can also do that by using a function which is set function, like we did for tuple. So in tuple we used braces, or we can use tuple method or function over there. So to create a empty set, be careful, you need to use set instead of curly braces, because empty curly braces create a dictionary by default, because dictionary also uses curly braces, right? And sets are mutable, meaning you can add or remove items like we did in list. However, the elements inside a set must be immutable, like numbers or strings or tuples. You cannot add a list as part of a set because it is immutable. So this makes a set a dynamic but structured tool for managing unique data, which is especially helpful when cleaning or processing input for machine learning models. So let's go ahead and jump to our screen and see how we can create sets. So there was one confusion that you might get. I said that you can create it in two ways. I will show you how. So over here, when you go ahead and use the function set compared to a curly braces, what is the difference? I will show you. So over here I say unique items is equal to set, and I am storing a list inside the set. So when I go over here and run it, you will see it has been saved as part of the set. But a few minutes before I said you that you cannot save a list as part of the set. Then how did it happen? Let me give you another example. So over here my set is equal to curly braces 1 comma 2, that is a list. Okay, now when I run this, you will see it is going ahead and giving me error, type error. It is saying unhashable type. That means it does not support a type list. Then how come it was able to store that value inside the set over here? The reason for that is when you're using curly braces, so it is considered as a set, and set does not support list as part of the element. That is why it is giving error. So over here it is going to directly save it as a set, but over here when you are using a method, it converts whatever data type or whatever elements you are giving it to it into a set. That is the reason you didn't got error while using set method, but when you are using curly braces and directly passing a list, it is going to give you an error. What we mean, what you understand by that, if you are going to go ahead and provide a mutable data type object inside this set, inside the curly braces, it is going to give you an error. But when you're going to do the immutable one, it is not going to give an error, because immutable types in set is not supported. Now let's go ahead and understand how you can add an element to a set. So to add an element to a set, you can use the method dot add, and you can directly mention the element that you have to add. So over here I have created first a set of mine with three values 1 2 3. So when I go ahead and say my set dot add 4 and print it, you will see that it is going to go ahead and add the fourth value inside my sets. Now how you can remove an element from a set. Now over here I have given you two examples. I will show you how these both are different and when you should use it and when you should not. So both does the same job of removing the element, but how it is different, let's understand. So when I say my set dot remove, so it is going to go ahead and remove 2, right? So 2 is available over here. And when I over here I say my set dot discard 10, 10 is not part of the list, right? But still I'm mentioning it. So let's see if it gives an error. Okay. Oh, sorry. I think I didn't run that. Now let me run it again. Yes. So over here you can see now 2 has been removed and the list has been printed. But for discard, I didn't got any error, right? Even though element does not exist. But now if I do the same for remove, If I go ahead and say 10 over here and run it, you will see it is going to give me an error, because the elements which does not exist, when you're going to go ahead and use remove, it is going to give you an error. But if the element does not exist and still you want to remove it, or you are giving, your code is giving that command of removing it, instead of giving error, it is ignoring it. So that is where the difference comes for set for the discard method compared to the remove method. So over here now, I will just go ahead and make it as 3, because so before that I will just go ahead and run this. So now it is not going to give me error, and I will go ahead and also put 4 over here, and now I will just change this. So you will see discard ignores also and it removes also. So let me run this. So now you can see two elements have been removed. Both are doing the same functionalities. One is ignoring if the element is not present, and one is not ignoring, throwing error. So that is difference, but the purpose is same. Now clearing all elements. So to clear all the elements, what you have to do is you have to go ahead and use the method clear, which is going to go ahead and clear. So right now we have 1 and 2 inside our sets. So now after running this, you will see it's empty. See, the set is empty now. Now, let's see how you can check membership inside a set. So for checking the membership inside a set, you can use this keyword in, by using which it is going to tell you whether whether it is available inside the set or not. So if I go ahead and run it, so banana is present inside our set. That's why it has given true. Grape does not exist inside as an element inside our fruits sets. That's why it has given false. Now if you have to make a copy of a set, you can also do by using dot copy function. So if I go ahead and run this, what it is going to do is it is going to go ahead and create a copy of the sets, and I have printed the new copy for you over here. So that is how it works. So let's jump back to our screen and see what's next. So next is set operations and methods that are recently covered. Oh no, set operation as a method that we are going to cover now. So over here you can see that different kinds of operators can be used on set for performing some task, and how we can do that. So Python supports a powerful operation based on set theory. So union combines element from both sets. Intersection finds common difference elements. Difference returns items only in the first sets, and symmetric difference finds elements in either set but not both. So these operations are especially useful in data pre-processing and feature engineering. So for example, intersection can help identify shared features across datasets, while difference can highlight new or missing attributes inside the dataset. So best of all, that sets operations are both intuitive and computationally efficient compared to other data types, so making them ideal for large scale data tasks. So let's go ahead and see how set operations work. So over here, I have used set operations. We are going to use different types of OR, and then difference, then symmetric difference, subset, and let's see how it works. So right now we have two sets 1 and 2. So the value of set is 1, 2, 3, 4, and this is 3, 4, 5, 6. So now let me go ahead and run this. Okay, now this is run. So let's perform a union of set 1 and set 2. So when we are performing a union of set 1 and set 2, it is going to print the union. So in the union, you will see it has printed the values 1, 2, 3, 4, 5, 6. So in union, it is not going to consider the duplicate values. That's why duplicate has been removed. And now inside the set, you will see 1, 2, 3, 4, 5, 6. Now we will do intersection. So when I go ahead and run the intersection over here, you will see it is doing intersection where it is finding the common ones in both of them. So that is how you are, because 3 is available here, 3 is available here also, 4 and 4. That's how intersection works. Now the difference. So when you do the difference over here, it is going to give you the difference as 1 and 2. Now when you're going to do symmetric difference, so the values for symmetric difference is going to be 1, 2, 5 and 6. And when you're going to perform a subsets, right now you are performing a subset that is less than equal to set2, and when I run this, it is also going to provide you the value whether it is a subset or not. And if you have to check the superset, that also you can do by running this. It is going to give you a boolean value as a return. Okay, so let's jump back to our screen and see what's next. Okay, so with the before going to official documentation, let me show you some useful methods also. So previously I was showing you that how you can use operators, right? Or sign and sign and everything. So many a times you don't recall it or don't remember it. So there are methods also, inbuilt methods available that you can use for doing the same job. So over here, if you are going to perform, if you are going to say union, it is going to give you the union in the same way that we saw with the operator over there. And if you're going to do intersection over here, it is going to give you the same value, the intersection. Then if you are going to go ahead and give the difference, it is going to give you a difference between the two different sets that has been defined. And symmetric difference, it is going to give you a boolean it is going to give you the symmetric difference compared to we are doing set1 dot difference set2, and it is giving us the difference, that is 1 and 2. Everything else is common now, and we are going to do symmetric difference. It is going to give 1 2 5 6 that we are doing on set2. Now when we go ahead and do the subset, for subset we have a method name is subset. If we want to check whether it is a subset or not of a specific subset, then we go ahead and define it. So what we are saying is set1 is a subset of set2. If I run this, it is going to give you the value true or false accordingly. It's not. Then for superset, set1 is a superset of set2. So it is giving false once again. Now let's go back and talk about another important aspect that we always discuss. So if I go ahead and take you to the official documentation that you should be aware of. So this is our first official documentation, tuples and sequence. So over here you will see many of the examples that we have spoken about is available over here. So you should also go ahead and have a look if you want some reference from the official python.org documentation. This is for tuples and sequences, and this is for sets. So over here also they have explained beautifully that how you can use sets and its various functionalities. So thanks everyone for your time and participation. I encourage you to experiment with the concepts we discussed today. If you have any questions or thought, feel free to drop them in the comments below. I would love to hear from you that what you are experimenting and where you are been stuck, and I can help you by replying to your comments. And remember, programming skill improve with practice. So try to apply these concepts in different contexts, that is different ways, to solidify your understanding. Join our WhatsApp community, subscribe to our AIML YouTube channel, and sign up for the Tech Insight Neuron newsletter, where very soon I am going to also share the blogs for all the videos that we are going to cover as part of this machine learning series. So see you in the next video. Take care and bye for now.